Welcome back to this series on architectural simplification. Today we'll be looking at read-write segregation, that is, the separation of read concerns to write concerns based on the specializations of each database that's being used in the stack. We've seen this migration path from a number of our customers who are hoping to consolidate their complex database architectures involving multiple moving parts into one database that serves the needs of their applications from both a read and write perspective. In today's example, I'll be ingesting data into a database that's specialized for writes, but not necessarily reads. I'll be using Cassandra for this. Cassandra models data based on queries. So if you need to perform lots of different types of queries, that might entail the duplication of the data into different tables with different index properties. I'll be using Debezium to get data out of Cassandra and onto a queue. And from there, I'll be loading data by another application into a database that does allow me to index data for different queries against the same table. I'll be using Postgres for this. At this point, you might be thinking, what differentiates CockroachDB from the combination of Cassandra and Postgres? Separately, both databases are very capable in a specific area. Cassandra is great for the fast ingestion of data, but what it's great for there, it lacks in query flexibility. If you start off with one table that's optimized for a particular type of query, you can't then retrofit it for another type of query. It can't be optimized for two very different types of query. You'd need to create another table that was optimized for the second query. Postgres offers great query flexibility, but it was never designed to work at the scales of Cassandra and Cockroach. CockroachDB brings together the scale of Cassandra and the query flexibility of Postgres. It kills two birds with one stone. Before we get going, I'll show you the infrastructure. I'm using Red Panda as my Kafka queue in this example. I'm building my own Cassandra image, and that will look like this. So I'll go from Cassandra 5.0, and then I'll install a bunch of things, including Debezium, that will allow me to then publish CDC messages onto Red Panda. And finally, I'm spinning up Postgres, and that'll be where I send data to for index purposes. The indexer itself is quite straightforward. It connects to Kafka and it connects to Postgres. I spin up a Kafka reader, which will be waiting for CDC messages from Debezium. And then I consume messages. I'll read messages off the queue, I'll unmarshal them into something my application can read, and then I'll upsert them into Postgres by way of an insert on conflict do update. I'm also taking a rolling average of the amount of time it takes me to get from the data loader, which I'll show you in a minute, into Postgres. The data loader looks like this. Again, very straightforward. I connect to Cassandra this time, and once every 100 milliseconds, I insert a row into my table. I'll spin up the infrastructure now. I'll create a topic on Red Panda. I'll create my target table in Postgres. That will simply be a product table with an ID, name, description, and timestamp. And then I'll watch for changes in Postgres. And this application will check the row count in Postgres every 5 seconds just to confirm that I've got data from Cassandra into Postgres. I'll run my indexer and then I'll connect to Cassandra. With these queries, I'll create a key space if it doesn't exist. I'll use that key space and then I'll create the same product table, but this time in Cassandra. And I've enabled CDC. With that all created, I'll exit Cassandra and run my load generator. And you can see that I'm now getting data in Postgres. This is data that's coming from Cassandra, being published by Debezium onto the Kafka queue, which is then being read by the indexer. And we're seeing an average delay of around a second, give or take. One interesting thing to note about this setup is Cassandra builds up a folder called CDC raw, and that needs to get built up by default to a megabyte before it's then flushed to a CDC index directory. At that point, Debezium can see the data and can then publish it. So in this setup, there'll always be a slight delay in writing data to Cassandra and publishing that data out. I'm not a Cassandra or Debezium expert. I found this setup to be quite fiddly with a number of moving parts, and there were quite a few parameters I needed to tweak in order to get acceptable performance into Postgres. I'm not going to create any infrastructure for the after scenario, and that's simply because there would only be one component, that would be CockroachDB. I can replace the infrastructure that I've created here, Cassandra, Debezium, and Postgres, with CockroachDB, simply because CockroachDB scales up for reads and writes. Because each node in CockroachDB is the same, you can scale as easily for writes as you can for reads. You simply add more nodes to the cluster. There's no third-party tools or awkward configuration parameters in order to get data directly from CockroachDB into downstream systems. Altogether, this means a simpler architecture because there's less for you to manage. And a benefit of not having so many moving parts is there's the potential for lower latency between writing data to the database and receiving downstream messages. With less infrastructure, there's less to manage and less to go wrong.